1.5 degrees Celsius doesn't sound like much. That's 2.7 degrees on the Fahrenheit scale. It's hard to believe that such a small change could make any difference to planet Earth. That 1.5 degrees Celsius is related to climate change, and climate change has been in the news. A little? Do we pay enough attention to climate change? Should we care more or less? Climate change is a complex, global, multidimensional issue. Why is it so complex? What's the goal? Are we humans making any progress on our goal? Are radical changes needed? And does our food system actually impact the Earth system? Let's take a look. Climate change is the large-scale, long-term shift in Earth's weather patterns and average temperatures. Since the mid-1800s, humans have contributed to the release of greenhouse gases into the air. This causes global temperatures to rise, resulting in long-term changes to the climate. Don't get me wrong, Earth's climate has changed throughout history for natural reasons, mostly small variations in the Earth's orbit. In the last 800,000 years, there have been 8 cycles of ice ages and warmer periods, with the end of the last ice age about 11,700 years ago. But natural causes can't explain the rapid warming seen in the last century. Just in case you had any doubts that our human activities are causing the climate system to warm, the Intergovernmental Panel on Climate Change, IPCC, reported since systematic scientific assessments began in the 1970s, the influence of human activity on the warming of the climate system has evolved from theory to established fact. Even NASA wrote, "It is undeniable that human activities have produced the atmospheric gases that have trapped more of the sun's energy in the Earth's system. Rising sea levels, melting ice caps and glaciers, more extreme weather events such as heat waves, droughts, floods and storms, and changes in biodiversity and ecosystems. These impacts can have negative effects on human health, food security, water availability, and economic development." Let's take a closer look at the complexities of climate change. Here's an infographic from Climate Council that is very high level but gives us the big picture of the Earth system. I know you know, but we are dealing with the natural world. There are interactions like between the atmosphere and ice, or the atmosphere and land. Changes in the ocean, land surface, sun, atmosphere, glaciers, and hydrological cycle form feedback loops, trapping heat in the climate system or causing ice to melt faster, for example. On top of the natural environment, we overlay human activities like our use of fossil fuels and animal agriculture. Now we can drill down a little more and focus in on the effects of greenhouse gas emissions and their links to climate change and health. Let's follow one set of linkages. As greenhouse gas emissions have increased, it has raised average and extreme temperatures, altered rainfall patterns, raised the sea level, and brought about extreme weather. This combination has increased flooding, heat waves, drought, and fire, which on one hand can cause loss of habitation and poverty, and on the other hand, the combination has increased ozone, particulate pollution, and even increased allergies to pollen, all leading to respiratory disease. But it's even more complicated. There are 5 factors that make the situation more convoluted. 1, it's evolving over long periods of time, decades to centuries. It's hard to see the impact of our actions today. Really, it's a lot like your health. You can consume meat, dairy products like milk, and ultra-processed foods like cookies, and you don't immediately gain weight. You don't immediately have a heart attack. Eating for convenience or because you like the way it tastes at the moment is a long, slow process that causes the health of our bodies, like the health of the planet, to decline. 2, climate change is influenced by human activities and natural drivers like solar activity and volcanic eruptions. That makes it harder to see and quantify our human influence on what is happening to the planet. 3, this is a global issue that affects and is affected by many different systems, such as the energy system, the food system, the water system, and the natural environment. One country's actions and choices can have consequences for others. This also means that the benefits and costs of mitigation and adaptation are not evenly distributed. 4, what about economic and political implications? There are conflicts of interest between regions and countries. Some regions may experience more droughts, floods, heat waves, storms, diseases, or conflicts, while others may benefit from longer growing seasons, more arable land, or new economic opportunities. And why would a country want to change, especially if they benefit from the status quo, or would have to pay more than others to transition to a low-carbon economy? Finally, climate change has moral and ethical implications. Questions about responsibility and accountability of different generations, countries, and groups. Finger-pointing and scapegoating are easier than solving the problems. All of these complexities probably make climate change the hardest problem facing the world today. So how do we get ourselves out of this mess that we created? Definitely not by doing the same things that are keeping us on this trajectory. That's the definition of insanity. Let's start with the goal, the Paris Agreement. The Paris Agreement is a legally binding international treaty on climate change. 196 parties at COP21 in Paris adopted it on December 12, 2015. To stop the runaway increase in global temperature, the overarching goal is to keep the increase to well below 2 degrees Celsius, above pre-industrial levels, about the mid-1800s, but ideally 1.5 degrees Celsius above pre-industrial levels. This is the level to prevent worsening and potentially irreversible effects of climate change. To limit global warming to 1.5 degrees Celsius, greenhouse gas emissions must peak before 2025 at the latest and decline by 43% by 2030. Where are we now? Let's look at 3 indicators. The first is global temperature. This graph shows the change in global surface temperature over time when compared to the long-term average from 1951 to 1980. Earth is warmed by more than 1.1 degrees Celsius, that's equivalent to 1.8 degrees Fahrenheit, above pre-industrial levels. Beginning in March 2023, record-setting wildfires affected all provinces and territories of Canada and parts of the US. A series of wildfires burned parts of Maui. Wildfire smoke has been strongly associated with bronchitis and other respiratory diseases. From July to August 2023, heat smothered large parts of Europe, Asia, and the US. NASA reported that the summer of 2023 was the hottest on record. This map shows global temperatures for June through August compared to 1951 to 1980. Higher temperatures put more energy in the Earth's system. Cloud formation increases. The air holds more moisture, all leading to increased rain intensity, duration, and frequency. Sure enough, heavy rains flooded regions in the northeastern US and parts of Europe and Asia. Meanwhile, a northern Himalayan state in India faced a devastating monsoon season with over 400 deaths and almost $1.5 billion worth in property damage. The second is carbon dioxide. Carbon dioxide is a heat-trapping gas that comes from the extraction and burning of fossil fuels, from wildfires, and from natural processes like volcanic eruptions. It contributes to global warming, which leads to extreme weather events, melting of glaciers, sea level rise, and ocean acidification, among other consequences. This graph shows the amount of carbon dioxide in our atmosphere in parts per million. We're at 420 parts per million now, when for a very long time CO2 did not cross the 300 parts per million line. The third is methane. Methane in the atmosphere has more than doubled over the past 200 years. It is a powerful heat-trapping gas and is the second largest contributor to global warming after carbon dioxide. It has an 80 times higher global warming potential than carbon dioxide and is responsible for about 1/3 of current global warming. But methane lingers in the atmosphere for much less time than carbon dioxide does, only about 10 to 20 years. What that means is methane is responsible for more short-term climate change, but acting on it can give a short-term response. About 1/3 of global methane emissions occur naturally, mostly from wetlands, but 2/3 are caused by human activity, including from oil and gas operations, coal mining, landfills, and livestock. So how do we address climate change? If we maintain the status quo, stay on this trajectory, scientists calculate there is a 50% chance that within 7 years, global temperatures will regularly exceed the 1.5 degrees Celsius above pre-industrial levels. This is the threshold for worsening and potentially irreversible effects of global warming. What we are doing is using up all of our natural resources, whether it's fossil fuels, trees, or water, without regard for the planet, ourselves, or even future humans. We are acting as if there are endless resources for endless growth in this closed system called Earth. That seems ridiculous to say, much less do. Yes, this Earth system is complex, but our measurement systems are excellent now, and we know enough. We need radical change if we want a sustainable future. We need to find harmony and balance in the Earth system. Our political and economic power structures must work for the common good because we're out of time. Radical change means changing our behavior and adopting more holistic approaches that consider limited resources in a complex system. Before I tell you what I think should be done, let us know what you think in the comments below. What radical change do you think would help the most? COP28, that is the 28th conference of the parties to the UN Framework Convention on Climate Change, recently ended. It was a global summit where governments discussed how to limit and prepare for future climate change and agreed on the need to transition away from fossil fuels in energy systems. Renewable energy sources like wind and solar are very effective alternatives to fossil fuels, and electricity generation from renewables is getting cheaper rapidly. We need to continue phasing out fossil fuels. But it's not enough to prevent the worst impacts. Much more has to be done to improve energy efficiency, reduce energy demand, and invest in other low-carbon solutions. I'll feature a restoration project in South Korea that provides flood protection for up to a 200-year flood event and reduce the heat island effect in the next edition of our email newsletter. 7410 Expanded is free. I love that you don't have to deal with ads while you're reading, and it's so easy to unsubscribe if you don't like it. Here's the link. One area that doesn't get much attention is animal agriculture and its impact on the Earth system. Did you realize that over 92 billion animals are bred, reared, and slaughtered for food annually? A UN Food and Agricultural Organization report estimated that 18% of global greenhouse gas emissions are caused by the livestock industry. The report was published in 2006, and the estimate may be too low. Using more up-to-date estimates, including livestock respiration, two environmental risk specialists at the World Bank and International Finance Corporation estimated that livestock products account for at least 51% of man-made greenhouse gas emissions. The livestock industry is also responsible for 68% of enterogenic, meaning of intestinal origin, nitrous oxide emissions. Nitrous oxide can remain in the atmosphere for up to 150 years and has a global warming impact 296 times greater than carbon dioxide. Livestock are also a highly significant source of methane emissions, about 35 to 40% of methane emissions worldwide. Add in the extensive land needed for livestock. Rearing livestock covers 1/3 of the world's total land and more than 2/3 of its agricultural land. And you have to wonder why we still eat meat. Scientists from Stanford University and the University of California, Berkeley modeled the effects of eliminating animal agriculture on greenhouse gas levels. They found that phasing out animal agriculture over the next 15 years would have the same effect as a 68% reduction of carbon dioxide emissions through the year 2100. This would provide 52% of the net emission reductions necessary to limit global warming to 2 degrees Celsius above pre-industrial levels. Greenhouse gases would be reduced, but more importantly, the land used today for rearing animals, grazing, and growing feed crops can be converted back to forests and wild prairies. Forests are so important for addressing climate change. About 1/3 of the CO2 released from burning fossil fuels is absorbed by forests every year. My family and I switched to a whole foods plant-based lifestyle, initially for health reasons. It was later that we learned the massive scale that animal agriculture contributes to environmental problems. The impact is so significant that it must be addressed now to complement phasing out fossil fuels. Hey, we really do appreciate your support. Please like, share, and subscribe for more. Pay attention to climate change, and remember to take it one day at a time until it's 7 days a week, forever 10.